Welcome to video number 2. We're going to be talking about how to solve a quadratic equation for the first time today. This is a really important concept. This is what the majority of our video lessons are going to be about, how to solve a quadratic equation. So here in video number 2, I'm going to start us with a problem that kind of calls back to what we did in the intro video a little bit. We have an equation here, y equals x squared minus 6x plus 8. And the question is, where does this graph of y equals x squared minus 6x plus 8 cross the x-axis? In other words, we're looking for an x-intercept. Right? And that's a concept that we've talked about before, both when we were dealing with just linear equations in class and also in the intro video. So hopefully you remember the big idea about how we find x-intercepts. And that's by making the y value 0. So, okay, well, I know how to find x-intercepts. I'm just going to make y 0 here and go ahead and solve for x. So I've done this before. And now we kind of get stuck because in the past, we've just had the x in one place. We've just been able to get that x by itself. We did 2x minus 6, I think it was, in the intro video, and we set that equal to 0, and we just got the x by itself. Now, in this case, because we've got an x squared and an x, they aren't like terms, we can't combine those two things together. So solving an equation like this is going to be trickier than simply getting the x by itself. So we have a quadratic equation that we have to solve here and find the values of x. That's our goal. All right, I have that here, written again, x squared minus 6x plus 8 equals 0. There are several different ways to solve quadratic equations. The one that we're going to start looking at today is a process called factoring. All right? And the idea of factoring is really just the reverse of FOIL, or the reverse of the distributive property. So we have this quadratic written out. We have the x squared out front. We have it in what we call standard form. The idea of solving by factoring is to break this equation down into smaller pieces that we call factors. Right? So what we're going to do here is think backwards and think, well, if I have this equation, how can I break this down into two binomials that if I multiplied those two together, I would get x squared minus 6x plus 8. That's what factoring is all about, breaking down this equation into two smaller pieces and then figuring out what to do with those two pieces to find the values of x. So let's think back to FOIL and think, well, when we did FOIL problems, how did we end up with x squared? Well, it was out front. It was the first times the first in our distributive property. We're going to multiply something by itself to get x squared. So what would work there? Do x times x. X times x would give us x squared. Right? Now the minus 6x, you might remember when we did the distributive property, or when we did the outer and the inner in the FOIL, we had to combine those two like terms to get that middle term. So that's a little bit trickier to find. So I'm going to skip that for a second and look at the plus 8 at the end. We got that plus 8 at the end by multiplying the last parts of each of our binomials in the problem. So what I want to do is try to think of some things that I can multiply together and get 8. So 1 times 8 would be a possibility. 2 times 4 would also give us 8. We could also have negative numbers. So maybe negative 1 times negative 8. Maybe negative 2 times negative 4. Should be a negative 4. Right? Any of those combinations would multiply together to give us a plus 8 at the end. So I've got to figure out which of those is the correct one to use here. So really, this could be a plus 1 and a plus 8. It could be a plus 2 and a plus 4. It could be a minus 1 and a minus 8. Or it could be a minus 2 and a minus 4. Right? All of these combinations are possible ways to get x times x is x squared, and something times something is a plus 8 at the end. All of these are what we call possible factors of our quadratic equation. So which of these is correct? Or maybe all four of them are correct. Only one of these four is correct. And the way to figure out which one is correct is to figure out which one gives us that minus 6x in the middle that we skipped over a second ago. All right, so in order to figure out which one gives us that minus 6x in the middle, we're going to do the other two parts of FOIL that we didn't look at yet. We looked at first times first. X times x is definitely going to give you x squared. We looked at plus 1 times plus 8 to give us 8, or any of these combinations to give us 8. But which of these will give us a minus 6x in the middle? We have to do the outer and the inner parts to figure that out. So in this first possibility, I have x times a positive 8. Well, that's plus 8x, to positive 8x. And then here, positive 1 times positive x, that's plus 1 more x. When I combine my like terms, 8x plus 1x, I've got 9x. I wanted to get a negative 6x. We want this to match this. They don't match, so these are not the correct factors. Right? So we move on to another possibility. We know x times x is good. We know 2 times 4 will give me 8. When I do the FOIL here, when I do my outer, x times a positive 4, it's a positive 4x. Positive 2 times an x, that's a plus 2x. And that gives me a positive 6x. Not quite what we want. We want a negative 6x. Right? We'll be able to talk later on about what this means, the fact that we got the right number with the wrong sign. Well, we'll talk about that. But for now, the plus 6x didn't match the minus 6x. We eliminate that as a possibility. All right. We move on and we try to FOIL here. X times a negative 8 is a negative 8x. Negative 1 times x is a negative 1x. Combine those, I get a negative 9x. No good. All right? And so hopefully I've saved the best for last here. Hopefully this is the correct one. I do x times negative 4. That's a minus 4x. Negative 2 times x. That's a minus 2x. Negative 4x minus 2x. Perfect. Negative 6x. That's what we were looking for. We want this to match this. It does match it. So we have x minus 2 times x minus 4. If we multiply those two binomials together, we get x squared minus 6x plus 8, which is what we were looking for. Right? So these are what we call the factors. These are our factors of our equation. Now remember, we're trying to figure out what makes this expression equal to 0. All right? So now let's deal with that fact. What we have is x minus 2 times x minus 4 equals 0. Each of those is a separate term. Now what I want you to do now is think about two numbers that you could multiply together and get 0. Right? Because that's what we're saying here. We've got something times something else, and I cover up, cover this up with my hand, cover this one up with the racquetball. Right? Something times something equals 0. So I want you to think of two numbers you can multiply together and get 0. I'll bet one of your numbers is 0, or maybe both your numbers are 0. Because the only way to multiply two things to get a 0 is if one of those is a 0 itself. So here's how we can use that fact to our advantage. I know that either this thing that was under my hand is equal to a 0, or this thing that I covered up with the racquetball. I'll cover up my other hand. One of these two things is a 0. All right? So either this thing, either this x minus 2 is equal to 0, or this thing, x minus 4, is equal to 0. Well, if x minus 2 is 0, what's x? 2. And if x minus 4 is 0, what's x? 4. So our two solutions are x equals 2 and x equals 4. All right? Those are our two solutions to our equation. Those are the two values of x that make this expression equal to 0. If I went back and I put 2 in for x, I did 2 squared minus 6 times 2 plus 8 in my equation, I would get an expression that's equal to 0. And that checks out. If I plug 4 back in for x into this expression, I would get an expression that if I simplified it, would equal 0. All right, so I've found the two values of x that make this statement true, that make this expression equal to 0. Remember also that this problem originally came from us trying to find x-intercepts, trying to find the values where this equation crosses the x-axis. So if you want to think about the graph of this quadratic equation, we'll be doing a lot of graphing later on in the unit. If you want to think about a graph of this equation, however this graph looks, this y equals x squared minus 2x, or minus 6x plus 8, we know the two places that graph will cross the x-axis now, at 2 and at 4. That's part of the story about what that graph looks like. We know a little bit more, I think, at this point about that parabola shape, that U shape to the graph, and we'll talk a lot more about graphing later. But I wanted to remind you of that because we used x-intercepts to kind of lead us into how to do this factoring idea. Okay? All right, so we had to go through several different possibilities there. I'm gonna shorten that up for you later on. I want to look at one more example together here. X squared plus 9x plus 18 equals 0. All right? We're going to try to solve this by factoring. Once again, x times x will give you x squared. And now to get 18, all right, well, I can go 1 times 18, go 2 times 9, go 3 times 6. Also the negatives of those things, right? Maybe negative 1 times negative 18, negative 2 times negative 9, negative 3 times negative 6 would all give me a positive 18. Now what you may notice is that we're going to try to get a plus 9x here in the middle. In order for that term to be positive, we really want both of these numbers to be positive as well. So I'm not going to really worry about the minuses here because when I FOIL, when I do my outer and my inner, I get negatives out there. Now, like I did with the last one. So I'm going to focus on these positive possibilities. And in fact, I'm going to jump right ahead because I think I've got a feeling this is x plus 3 and x plus 6. Right? And the more you do these, you'll get better at kind of noticing which ones are going to work best for you. X times x gives me x squared. 3 times 6 gives me 18. Then when I FOIL, and this is the key, that outer and that inner need to combine to give you a 9x. All right? Outer and the inner need to combine to give you what's in the middle here. Once we find the correct factors, they're correct because this 9x matches this 9x. We think, all right, one of these two factors has to be a 0. Either the x plus 3 has to be a 0, or the x plus 6 has to be a 0. One of these two factors is 0, and then we solve for x. Right? X could be negative 3. X could be negative 6. Those are my two solutions. Again, if I plug that x value back into the equation to check it, this expression would equal 0. If I plug this back into the expression, it would equal 0. If I graphed this, if I graphed y equals this expression on a graph, these would tell me the x-intercepts. Negative 3, negative 6. Would tell me that graph, that U shape, would cross the x-axis at negative 3 and negative 6. All right? That's the intro to factoring, some of the basics. We'll start practicing factoring in class tomorrow. We're going to spend more than one day on this. So the key right now is to look at these two examples, make sure you're understanding the process of how we do it, and then we're going to work together on some problems in class to get us better at it. Okay?